In this video, we're going to continue evaluating algebraic expressions with exponents, and we're going to do so by looking at a few applications. So let's dive into one. We want to find the area of a certain circle. The area of a circle is given by the following formula. If A for area equals pi, pi being 3.14, it's also the ratio of the circumference of a circle to its diameter. Well, that's not too important to know. We do want to know that this is a specific number and not a variable. So we have area A equals pi times r squared. R is the radius of a circle. If we draw a picture of the circle to get a better idea of what we're dealing with, r is this distance right here. The distance from the middle of the circle to the outer ring. This right here is our radius. Okay? And we want to find out what the area inside of this circle is. Now, we want to find out the area of the circle with the radius 12 inches. We're given the radius is 12 inches. Okay, so this distance right here is a length of 12 inches. And we know how to do this. We know how to evaluate expressions when we're given the value of a variable. So let's go ahead and plug 12 in everywhere we see for r. So let's say we have area A equals pi times r, which is 12, squared. Order of operations says we deal with the exponent first before the multiplication, so let's rewrite pi. 12 squared is 144. And then pi times 144, we can do it with a calculator. Pi, like I said, it's a non-repeating, irrational decimal that just keeps on going forever, so we actually always will be approximating when it comes to pi. It's just how many decimals you want to round to. Here, we're going to get 452.38, and that's rounded to 2 decimal places. And this is going to be in square inches. Now, you want to check with your instructor as to how many decimal places they prefer, but 2 is usually the norm. When you get up into calculus and higher mathematics, you'll find you'll be rounding to 4 decimal places just for a little more accuracy, but for now we're going to stick with 2 decimal places. But again, check with your instructor. Okay, let's take a look at another one. Let's say we want to find the height, h, in feet of a ball in flight. And the ball in flight, the trajectory of it is given by the following formula. We have minus 32 t squared plus 80 plus 80 times t plus 25. Okay, so we have a ball in flight, whether we threw it or kicked it or hit it with a bat, and its flight is described by this expression right here. Okay, where height is in feet and t is time, which is in seconds. T is in seconds. We want to find the height of the ball at a time t equals 2 seconds. So t is going to equal 2. And what we're really doing here is we're going to plug in 2 everywhere we see for t into our expression. We want to find the value of the flight of this ball after 2 seconds. And we know how to do this. So we have minus 32. Everywhere we see t, we're going to plug in 2. So we have times 2 squared plus 80 times 2 plus 25. Order of operations says we deal with the exponent first, so we have minus 32 times 2 squared. 2 times 2 is 4. Rewrite the rest. 80 times 2 plus 25. Okay, now we can go about our multiplication. Minus 32 times a positive 4 is going to give us a negative 128. Positive and a negative will multiply to give us a negative. 80 times 2 is 160, and plus 25. Working from left to right, we have a minus 128 and a positive 160. 160 is bigger, so the positive wins out. It's going to give us a positive 32, rewriting the plus 25, and finally adding these two, 32 and 25 gives us 57. So the height of the ball at t equals 2 seconds is 57 feet. And that's our answer. All right, I think we're getting a handle on this. Let's do one more. Let's take a volume problem. Let's say the volume of a box without a lid is given by the following formula. Okay, so we have a box. The volume V equals 3x times 8 minus x squared. Okay, where x is going to be the length in inches. We're going to define our x as length in inches. In inches. Okay, and V is the volume of the box. The volume in cubic inches, or in inches cubed. Okay, we want to find out a couple things. First, we want to find out what is the volume if the box is 3 inches long. Okay, so when x equals 3, the length of the box is 3 inches. Well, we know how to do this. We're going to let x equal 3, and we're going to, everywhere we see x in our expression, we're going to plug in 3 for it. We're going to substitute in a 3. So our volume V equals 3 times x, which is 3, times 8 minus x, which is 3, squared. Okay, we have a little bit more to do than we had in the last problem. We can go ahead and multiply these two 3's together, since it's outside. And then we need to deal with an exponent, but the only thing that comes before exponents is parentheses, so we're going to work from the inside out in the parentheses. 8 minus 3, or 8 plus a negative 3, gives us a positive 5 squared. Okay? We're going to rewrite our 9 because our exponents come before multiplication in our order. 5 squared gives us 25. And 9 times 25 is 225. And this is going to be in cubic inches. So the volume of our box that's described by this expression, when x equals 3, so the box is 3 inches long, the volume is equal to 225 cubic inches. Okay, now let's determine what is the volume if the box is 1 inch in length. Well, we simply plug in a 1 every time we see x. So when x equals 1, the volume V is going to be 3 times 1 times 8 minus 1 squared. Go ahead and join our 3 and our 1. 8 minus 1, or 8 plus a minus 1, gives us 7 squared. Exponents come next. 3 times 7 squared is 49. And 3 times 49 is 147. And this is given in cubic inches. So when the length of the box is 1 inch, the volume of this box, which is defined by this expression, is 147 cubic inches. And when a box is 3 inches long, it's 225 cubic inches. Okay, so we saw a few examples where evaluating algebraic expressions involving exponents can be very useful. We saw it in geometry here, another physics problem, and another geometrical problem. Volume is actually 3D, so those are actually very useful in practice. We want to be able to get this down, and I'll see you soon.